Hey guys, in this tutorial I would like to show you how you can build a procedural traffic light in Houdini. We'll start by making an individual frame box that will hold our glass piece and LED lights, and after that we'll focus on creating the main pole and the side extension arm onto which we'll stack up our traffic lights. And at the end of the video we'll see how you can expose the parameters that will allow you to have control over the length of the poles, traffic light position, rotations, number of lights, and so on. So if that sounds interesting to you, let's dive into it. Okay, let's get started. Drop a geometry node with a traffic light. And we can start really simple with just with a line. Okay, let's place it like this. We'll place it along x-axis here. And then let's also position it like so that this middle point here matches with 0. So let's just grab a length. We copy it parameter and then we paste relative references here. Divide it by 2 and then let's negate it as well. Like this. So it always stays in the middle. Okay, so what can we do is we can resample it, so we'll give us more resolution to the line, and then we can build like a curve out of it. So let's look at our references. So like if you look at the traffic light from the side, you can see it's curved here. So I'd like to be able to build that as well, and be able to control it. So how much you want it to, you want this front face to protrude. I was lucky enough to get like real dimensions of this traffic light because I went to the official website, and yeah, they provide all the dimension, which is great for us. So now let's like build the bottom part here, extrude it up, and then let's first build like this front part. Then we will do the back part, and then we can join them together. Okay. Okay, so let's set this to 0.33, more or less like this, like the real size, and then resample. In here we can say maximum segments. Let's disable this. You can play with the resolution. Okay, and now let's build a function where it allows us to curve it. Okay, you can drop a point wrangle. So in the point wrangle, let's run over the points and the position of in z-axis. Okay. This equals, and then we can build the ramp. Okay, so let's write ch ramp. And you can see here the ch ramp, and it needs string channel. So this is the name how we're gonna call our ramp. We can just say, for example, profile, and it also will need a float ramp position. So it needs to know the position, of the points in space. So I'll show you in a bit where to get that. So let's just name it. We say, for example, say profile. Okay, and the position, we can actually, let's go back here. And we can enable this attribute. It's called curve view. Here. And this is exactly what we can put here. So let's say at curve view. Okay. Semicolon. This, and then if we hit add spare parameter, see what it does. Let's just extend this. Hit here and change the interpolation to B-spline so it's more smooth. And also this point, change it to B-spline. And we can hit here to add a point. So let's select the last point and then bring it down like that. And then the middle point will be able to control the curve like that. So we can, like change it however we want. It's quite sensitive here actually. So to be able to have even more precise control, we can add another channel here. So we can say like multiply, and then let's add a channel CHF. And we say, for example, let's name it as profile amount. Hit it one more time. And then with the profile amount, you see, I can now have this slider and control how much curve do I want. Just gonna set it like to put in the middle, 0.5. Okay, now let's poly extrude this. So I want to move it up. Let's say point normal, but as you can see, it's moving it down. So in this case, let's set up our normals first, and then we can poly extrude. So because poly extrude is just basing these extrusions on where our normals are facing. So we can, for example, do it in here super quick. Drop another point wrangle. We say normals up. We can just put normal equals, and we set it to Y axis. Yeah. So they're facing up. Okay. And we here change from precompute to attribute. So it's using our normal now. Okay. Set it like this. Extrude up. I like to rename my node, so later on when everything is growing in size, when we keep adding nodes, I know exactly what I did. So it's really useful. So now let's use we can use another extrude to give volume. And this time I want to extrude it into the Z direction. So we'll do it like this. So what it does as well, like if we change it to point normal, nothing changes here. You see how it extrudes outwards. What I would like to have, if we look at it from the top, I would like the sides to be straight, like in our references. So I want it to be straight, not to the outside. So we simply can, again, reuse this node that we created to set our normals. Let's enable it. Okay. And then this time we say, instead of y, look at z direction, right? And we can reconnect. Now we change to point normal attribute, right? And now it's straight. Nice. Okay. So next step, what I would like to do as well is, since this part here, I would like to have a face as well. So let's output back. And also I would like it to be straight, like flat, lying flat here, because if we take a look at our references again, like this is where at the back it joins with the other side, right? So it needs to be flat. So let's do that. We need to find a way to group the points that just at the back. So what we can do here is tick this box back group, which is extrude back. You see this name. So it should really group all the points that is on the back, but it's only grouping the primitives, not the points. So we need to find a way to promote a primitive group to the point group. Okay, so what I'll do is let's type promote. We do group promote, and we can convert from auto detect to points, and let's select here extrude back, right? So it's just selecting only these points. And then we can again use a point wrangle and do a little conditional here with a if statement. So to say, if the points belong to extrude back group, then move those points to 0 in z axis. Okay, so we can say if, in brackets, let's use the in point group. Okay, so for example, if you want to expand on this, you can just hover your mouse over this and hit F1. It'll show you this documentation, what it requires. So it says here, for example, an in-point group, right, returns 1 if the point specified by the group number is in a group specified by the string, basically meaning locates the name of the group, locates those points, and then we can say move them to the 0. Okay, so it needs the geometry, which in our case it's incoming geometry, so it's gonna be 0. Then we need to specify the string, so the name of the group, in our case it's gonna be extrude back. So extrude back, and then it needs to run over the points. So point ptnum. Let's close this. Then do the curly brackets. So in here, hit tab. Let's say then if it's in this group, take the position of the points. So we specify z, only z, right? And then set it to 0. that. Yeah, let's see. And let's see if it works. I'll shoot. If we disable, yeah. So with this, you see, it's basically flattening the back. So let's see. Say extrude to the front. Just do a bit less. Something like that. And we flatten back. Okay, let's bevel some of the selected edges because I wanted to make it round. And what we want to achieve here is those nice round edges here, right? We will bevel these two, and then also we want to bevel like the back of it, you know, to make it round as well. So let's do that. So we can group first this edge on top and this one on the bottom. Let's say, let's create a group. We can call it, for example, H bevel. Call it H bevel. Let's set it to edges. And then we can disable the base group. And let's use the keep in bounding regions option, right? So what it gives us is, it gives us this bounding box, okay? So we can make it much smaller. Let's say I do it like something like that. And also in Y, and then in Z, I'm not really bothered. I can stay the way it is. And so I want to avoid manual placing. I want it to be like, you know, procedural in this way. So what we can do is, because with the center, we can offset this B box. So let's say we type B box expression. Okay, so it's taking the bounding box of the incoming geometry, which is our current box, right? And we can say, okay, move this to the very top or to the very bottom of our geometry, right? This is what it says here, type. There are various types. So for example, if we are now dealing with the X axis, we can say D X max or DX min, stuff like that. So let's type, for example, 0. So it's incoming geometry, D, and then we say X max, like that. So as you can see, it pushes our bounding box to the very top. Okay, and then here we can say the same. B box 0 Y min. Okay, now let's repeat the same process. Just duplicate this. You can say group bottom edge, group top edge, that, and here we're just gonna say in Y we change it to max, So it selects the top edge. And also initial merge, we can change to union with existing, right? So it merges these two groups together. And now we can perform bevel on it. Say poly bevel. All right, let's specify the group, which is edge bevel. Okay. Then do it like this. Then let's increase the divisions, make it nice and round. Something like that, okay. Okay. Also, I would like to now bevel this edge over here to make it round. I could have just done, I could do the same operation again for this, but I would like to show you a different technique just for the learning opportunity. I'll do something different. Let's grab this one here, and then let's create a reference copy. Okay, we create a reference copy. And then we're gonna delete these channels here. We're gonna hit delete, delete channels, and then we're just gonna untick these parts. Okay, so we're only left with front-facing mesh. Okay, and then all I'm interested is selecting this this edge over here, right? Because poly bevel works with edges. So what we can do is drop sort. Sorry, drop sort. Sort node. Let's enable the point numbers, and then we will sort by X. So what it does, it's since we're sorting by X-axis, it's the first point becomes 0, and the second point here on top becomes 1. So it's a non-destructive way of grouping something, because if we change the segments here, no matter what we do, left points always stays as 0 and 1, which is pretty cool. So let's group it. We just can call it bevel. Let's say we select, we will select like the points. Save all this. And then wait, in the base group, we just specify 0 and 1. Let's select just these points. And then for bevel needs edge group, not the point group, so we can promote again. Let's promote. Say bevel to edges. And then also we need to check this, include only elements entirely contained in the original block. Okay, like that. And then what we want to do now is to transfer this edge to this geometry here, right? So we can do it with the group transfer. Let's see, where is it? That's the one. Let's connect. Transfer edges. Can untick this. We're interested only in edges, and then we select bevel, and we need to reduce the distance threshold. Let's put it something like 0.1. So it passes this information to our box geometry, right? So we have it here, and it's called bevel. Okay. Now let's bevel it. Alt bevel. Increase divisions, and then we can go all the way. Yeah, we want it to be really round. So let's settle on 0.1. With this, we have like a 2 points laying on top of each other. So we want to use them. We can use fuse. So we have our box here, right? So what we want to do now is also add another bevel on these edges here. That's a lot of beveling going on. So having another one. When we do bevel here, you see it's beveling everything, all the edges. One way to deal with it is use exclusions. So if you tick ignore flat edges and increase the normal angle, and see it only starts to bevel these ones. So I'm pretty happy with the result, but the only thing is like it's also beveling the back side, which I don't really want because we'll show you like on our references, we look, the back side is actually quite flat because there's bevel at the front, but not at the back because it's going to be joined by the other shape here. It needs to be flat. So let's deal with that. We need to kind of find a way to isolate just this front facing edge, okay? We can make another group, for example. Oh, let's say group. Say group back edges. Set it to edges. And then we can keep binormals. We can enable this. So let's group binormals. So decrease the spread angle. Now we need to reverse it. So -1. Now it's gonna select only the edges that are facing Z direction. 76. Yeah, that's good. Let's call it, for example, frame back. Okay, we have this. Let's plug into polybevel. We can bevel it by group. So if we say frame back, it's beveling just the back, but not the front. So we need to reverse that effect. One easy way to do it, if you put an exclamation mark before your group, it reverses the effect. So it's like except frame back, bevel everything except for frame back. Okay. So now you see we are beveling just this part, but not the back. And this is what we wanted. Okay. Let's see what we can do. Something like this. All right, and then I think pretty much done with this front frame. So let's name it null. We have front frame. Okay, and then in so now we will follow up with the glass part, that runs through the center of the box. Let's do that. Okay, and before we jump into the glass, also let's make one little step with let's cut out this hole here where the pole will be inserted. Okay, let's take a look. Talking about this piece here. Okay, and we also need to do this little bump going up, so it can be observed here. We can do tube. Start with the tube. Let's increase the columns, and also we need to reduce the scale. Something like this. So I want to make sure that it's always higher than our traffic light box, because I'm going to basically boolean it out. Okay, so I want to make sure that, let's find this poly extrude up where we added the height. I'm gonna grab the distance, copy it, move it back, and then we're gonna set it as our height. Paste. Okay, so now it's the same size, and I'm gonna multiply it by 2. Like that, just to make sure it's higher. Also, I want to set it on the floor. Okay. Put it here, and then divide it by 2. So it's sitting on the floor. We can enable caps. So let's switch on this template. Want to see what's going on. So this hole happens on the left hand side here. We want to move it, but we want it to be contained within this box at the same time. So in match size node is great for that. Pole. Match size here. So we're not really interested in changing the Y and Z direction, so we can set it to none. So it remains the same. All we want is the X. So let's do minimum to same. So minimum to minimum. So it moves it to the left side. And we can offset it a little bit here. Like so. Bit of offset here. I'm gonna call it pole cutter. We might use it later on. And then let's do our boolean. That will be subtraction. Okay, so we have it here. Let's disable this. And then we subtract that. Okay, so have that. Now I want to be able to do this little bump on just right on the edges. And it's if you enable A, B seams, this one, output group, actually does exactly what I need. This where the intersection happens, enables this group, so I can isolate it, I also want to delete for now this back part, because that's gonna make my life easier when I deal with this little extrusion. So what I'll do is I drop delete. And I'm gonna do again normal enable. And then I'm gonna set it to -1, so it just deletes this part. So let's do a bevel. Bevel. Let's do just AB seams and create like a little opening, maybe just 0.03 could be fine. Now we're gonna output also the group here called edge fillet polygons. Let's do poly extrude. Okay, and this time I'm gonna hit edge fillet polish and do a tiny bit of an inset here. Just a tiny one. Right here. Okay. Now the extrude. And now in here, let's go back and let's hit back group, extrude back. Let's try with the extrude back. I think that's what we want. So now when we extrude, we don't extrude just everything, but only this group. If it's, let's see if it's extrude back. No, then it's probably front. Extrude front. Go right now. Extrude front, yeah, okay. So we extruding front. Okay. Something small like that will do. Yeah. Yeah. Okay. Confuse again. In case we have some loose points around. Okay. So we're gonna fill this hole. I'm gonna do single polygon, you know, for now. Later on, I will triangulate everything, so we will get rid of the n-gons. Reverse this. Okay. Now we're gonna create a box. Like that. And then with this box, let's place it again on the ground. I want the height of this box to be the same as our extrusion again. Here. Okay. x-axis is going to be also the same. We can say, let's just, instead of using this, we'll delete it. Let's use the size instead. And then divide it by 2. Okay, so it's sitting on the ground. And also, let's shrink this. I just want to have it like enough length here to, if I enable this template, just enough length to push through the box, you know, with our boolean. So like this is okay. Now let's decrease our scale. That. Okay. We can use match size again. Okay, so let's do max to the same, maximum to maximum, and use our offset. Then, okay. Now we also need to bevel those edges to match with our frame. So I can go back and use the bevels that we made here, and we can basically use the same distance and divisions. So bevel. Here. Okay. And also divisions. All right. So let's see what's going on. Use a boolean. A boolean subtract. Okay. I would say that since the size of this inner piece is it's a bit smaller, so our bevel doesn't fully match. What we can do is go right here, and we can multiply it. So we're happy. Like, let's eyeball it. Maybe this is a bit too much. Like this. Yeah, I think it's okay like this. Okay. All right, now let's check out our reference. So in here, we made this cutout right here. So we will also need to create a glass piece, right, that runs on top of our frame. And also what I would like to do is like do this little split that happens between two pieces like that. Let's do that as well. And here we can actually enable AB seams again. And use a bevel. Use AB seams. Just give it a little bevel as well on the edge. Okay. Then let's group the back first. It's gonna create a little bit of extrusion here, and that will be our split. Okay, let's do normals. It's fine. And then this one. So we can call it split. We can do poly bevel, or let's do extrude. Use our split. We can also insert it inside that. Let's adjust. So it's like inserting inwards. Okay, yeah, that should be enough. That should be enough. Also, since we created this extrusion, I would like still to our box to sit on the on our 0 line. So let's push it a little bit to the left again. Can use transform. And here we can just copy the distance. And then Z translation over here. So it sets it back to our initial position. So imagine like when we have our back frame joined together. Change the direction here. Right. So once we have this part modeled as well, we will have this gap running here. Okay, so delete that. Okay. Now let's with the front frame we're pretty much done. So let's triangulate it. Use a divide. Don't generate slivers and avoid small angles, you know, like that. Okay. We need to, let's enable smooth shading. We can do smooth shaded. You can see we have some shading issues because of the normals. Let's set the normal. And do it by face area. Okay, good. Just want to have like a sharper edge here. So I'm gonna dial it back a bit. that of h. All right, nice. Okay. And then let's name it. Okay. If you hit L, then this will organize your nodes. Pretty handy. Okay, let's do the glass part as well. So what we can do with this one is since we created this say call it a glass cutter, right? Also, I'm gonna have another null here. Okay, that will be our glass cutter. So we can duplicate this boolean, and this time instead of subtracting, let's do the intersection. We'll do intersect, another mode, and that's an easy way, I think, to extrude the glass finally here. Now, if we delete everything apart from this front-facing mesh, then should be quite easy to do, you know. So let's do delete. Say normal. We can do -1. See. Like that. Okay. Say here, let's intersect. Now I'm going to give it a little bit of thickness. Okay, and then let's output the back as well. Now, and play that, see how it looks. So it's protruding at the moment. In our photos, it's actually inside, so we can move it back. Okay. Push back. And let's push it a little bit back. Like this, yeah. Okay. And then we can also triangulate this. Like so. Also, if you want to be able to actually see through this, because it will be quite helpful at later stages when we're gonna model some stuff, like some stuff inside of this frame box. Let's add some opacity to this glass. Okay, you can do it very quickly with point wrangle. Put here. For instance, here we say alpha equals It could be anything from 0 to 1. So let's say 0.5 semicolon. And that gives us a opacity. So just dial it so you can see what's happening inside. I think I'll keep it just like at 0.3. Okay, let's also do our normals here. Okay. And we can name it glass. Okay. Okay, so this is our piece. And then what I'm going to do now is just to organize my nodes, see if the naming makes sense. And then we can wrap it into the network box. So for example, if you just select this, then click here, we can name our pieces so we can be more organized. Let's say glass. Scatter. Right, and we can merge these ones for now. And this one, we can call it frame, say front.